This device here is known as a manometer. Mana. Mana. Yeah, I've been waiting all semester for that. So it's just a long piece of tubing that's shaped in a U. And we'll see at the moment, because nothing funny is going on pressure-wise, you have the top end is at atmospheric pressure, and the bottom end is attached to a syringe, which is also at atmospheric pressure at the moment. So we see that the water level is equal. And then what I can do is I can squeeze, I can squeeze this, and it becomes unequal. So I've applied pressure to the left side. So you see it's attached here. I've increased the pressure in this tube along the way here, which has then caused a net push. It's a larger pressure on the left side than it is on the right side. So that means you have a net push from the left to right. And now you can see it's beginning to equilibrate because there's leaks in this tube. So the pressure is beginning to become equal to atmospheric on the left side again. But this is able to let us measure what that pressure is simply by getting a change in the height. So alternatively, I could take this and I could pop this back out again, and I would lower the pressure on the left side. So pressure is lower on the left side, so we're able to get a difference in height here between the left and the right side. And that difference in height, just from density times g times the change in height, is able to show us what the pressure difference is. So this was kind of an old-fashioned way of getting pressure difference measurements. Sort of like having a barometer is able to help us determine atmospheric pressure. For instance, this is a way that we can hook up something that is able to generate an increase or decrease in pressure and find a way to get what that pressure difference is. Let's do a quick pressure measurement here. So I've zoomed in a little bit, and what I'm going to do is I'm going to take this syringe, which is currently set at 2 milliliters, and I'm going to compress it to 1 milliliter. And well, it's not quite a true measurement because we have all this pipe that's hanging here that it's going through. So so the air is definitely a little bit more than 2 milliliters. But I'm going to compress them from 2 to 1, and we're just going to, I want you to get height measurements and determine what is the change in pressure in pascals. So I'm going to try to do it slowly, but you have to get a measurement pretty quickly because the fluid begins to try to equilibrate itself with the little leaks. And then I'm going to compress. And you should pause. And when you pause the back there, when it was at its greatest level, you should be able to then get that height difference and figure out what the pressure difference is between these two sides in pascals.